So use what you just learned to combine or expand the given expressions. So obviously if you have two logs that have been separated, you want to combine them into one, and then go the other way as well. If you have one log, you want to be able to expand it into two. Now we're not going to find the value of the log right now, we're just going to combine it into one single one. So looking at letter A, what would we do based off of what we just learned? Multiply the 5 and the 3. So this would become log base 2 of 5 times 3, which we would want to simplify to log base 2 of 15. Nice. Okay, letter B is actually over here to the right. I would want to expand letter B because it's come to me as a single log. So how would we expand two logs that involve multiplication? Would we separate them using addition, subtraction? Addition. So we would separate this as log of 10 plus log of 100. Oh, I should have moved that over. That's weird. There we go. All right, and by the way, what's the base there? Because there's no base written. 10, good. All right, letter C. Why don't you guys go ahead and finish these with your partner, and then we'll come together and check them.
Which is just there's no base that is
Fine if you had log of 1/10, but I do want you to see how you could take that technically further. 1/10 can be rewritten as 10 to the negative first, right? And then technically, couldn't we also use the power property to expand it all the way to the opposite of log of 10? So just so you know, you might see this even in the answer key in the back of your book, and it's not necessarily that you did something wrong, it's just you could possibly go further. Now this is perfectly fine if you left it as log of 1/10, but just so you're aware that sometimes you can see things going off further as well. Okay, let's take a look. Let's write down these general statements. General statements, first of all, we have the product property. Product property, which states that if you have log base A of any number x plus log base A of any number y, then you can combine them into a single log as log base A of x times y. And then just so you know, this is a reversible statement, so you can combine going forward or expand going backwards. Then next we had the quotient property, which states that if you have log base A of any number x minus log base A of any number y, it's equivalent to log base A of x divided by y. And again, that's a reversible statement. And then last but not least, we do have the power property, which states that if you have n times any number times log base A of x, you can bring that into a power by rewriting it as log base A of x to the nth, which shows that n becomes the power. And again, this is a reversible statement. Okay, you all picked up on the rules very quickly. So the rest of our focus is going to be how do you use them when there's many rules involved in one. So let's take a look at, first of all, when you are expressing each of the following as a sum or difference of constant multiples of logs, aka when you're expanding one log into the sum or difference of constant multiples. Now, step one is if you have the power prop or the exponent, an exponent involved, you want to apply the property involving the exponent first. And you'll see how that shows up in a moment. Then you would begin separating using properties involving addition or subtraction, aka the power or the product and quotient property. And then finally, you would want to work with the exponent again at the end, and you'll see how this all comes into play in the next few examples. So let's take a look at example 1. Example 1, we have log base 2 of 6x divided by y. What do you think we would do to separate this? Any ideas of what we would do first, maybe? So you could use the quotient property first to separate those. So yes, we could look at this as log base 2 of 6x minus log base 2 of y to get rid of that division sign. And then how would we separate the 6 times x? With addition or subtraction? Addition, because it's the product property. So we would separate this with log base 2 of 6 plus log base 2 of x minus log base 2 of y. There's no power property that's been used or no power property we need to end with, so this actually would be our final answer. Example 2. Example 2, I do see needing step 1. Step 1's important here. I need to first work with exponents that are involved before I can separate all the numbers underneath. How can I change the cubed root to an exponent? 1 over 3. Excellent. Remember, guys, the number in the crack of the radical goes in the bottom of the fraction when you convert it to exponent form. Probably the weirdest lesson I ever taught. So we have log base b of this value, m to the 5th, n to the 4th over t squared raised to the 1/3. Now there's different ways you could go about this. I usually apply the 1/3 inside first, just to simplify that component. Some people use the power property out in front, but then use parentheses around everything they do within. But just because in my opinion, this is easier, let's go ahead and let's apply that 1/3 within, because you know if you raise an exponent to an exponent, you do what? Multiply. So this becomes log base b of m to the 5/3 n to the 4/3 over t to the 1/3. Sorry, thanks guys, 2/3. What would I do without you guys? 2/3. And now we're going to wait to apply that exponent until the end. So we've simplified it all together, and now we won't apply the power property to the end. So how do we separate the m to the 5/3 times n to the 4/3? With addition. And then what do I do with the division sign? Subtraction. So this becomes log base b of m to the 5/3 plus log base b of n to the 4/3 minus log base b of t to the 2/3. And then finally, I have not expanded fully because I still have this exponent up here. So what would I do with all of these exponents? Bring them in front of the log that they're next to. So I'm going to bring the 5/3 here. I'm going to bring the 4/3 here. I'm going to bring the 2/3 here. And that would be 5/3 times log base b of m plus 4/3 times log base b of n minus 2/3 times log base b of t And then is there any last thing we could do to simplify this? Do you guys see any GCF maybe we could take out? The 1/3, right? So we could divide out the 1/3, and that would be 5 times log base b of m plus 4 log base b of n minus 2 log base b of t. And that would be our final answer expanded. I can't do any more to that, to expand it more. Any questions on that? All right, let's flip it to the back side then. When you're writing each expression as a single logarithm, sometimes you'll see the directions say combine or condense. You are going to take all the logs and condense them into one single logarithm. The nice thing is the steps remain the same. You're just kind of going backwards. So you're going to apply the exponent property if necessary first. Then the properties using addition and subtraction. And then the exponent again at the end if necessary. This first example 3 is kind of the warm-up example. Why don't you try that one with your partner and then we'll go ahead and check it together. Make sure that you guys did. Make sure you have it as a single log. So it would be log base a of x times y divided by m. Sometimes I'll see people wanting to divide by a log, but that's just not using the property effectively, so make sure that you just have it as a single log. Okay. All right, example 4, this is where it gets fun. Example 4, what do you think we should do first? Yeah, you could distribute the 3, that would be good. Okay. So if I distribute the 3, I would have 3 times log base b of 2y plus 5 minus 3/2 times log base b of y plus 3 minus 3 log base b of y. Right? Whoa, what did I do? Something. There it is. What will we do next? Which property do we have to work with first? The exponent, the power property. So I need to take all of these numbers in front and bring them back to their exponential form. So I would do that, and that would give me log base b of 2y plus 5 raised to the 3rd power. Now here's the nice thing, if you took the negative 3/2 with you, because of the way the rules of exponents work, in the end you'd still have the same answer. I'm going to keep the minus sign here, just because in my opinion, I don't know, I think it works nicer, but both ways would work. So minus log base b of y plus 3 to the 3/2 minus log base b of y to the 3rd power. Here's a good question. We worked a lot on this first semester. Should I distribute the 3 in if there's a plus sign? No. No, good, because that would really be 2y plus 5 times itself, which we know would involve a lot of foiling. It would not simplify to 2y cubed plus 5 cubed. So don't distribute that in if you have the plus sign. Okay, now how do we work with the minus sign? Division. So let's go ahead and do that. That would give us log base b of 2y plus 5 quantity cubed over y plus 3 to the 3/2. And I still have this minus log base b of y cubed. And then finally, I would need to use the quotient property again with that minus sign. So again, I'm going to be using division. I'm going to go ahead and carry this over to here. Let's actually, you know what? I can zoom in. I forgot I could do that. Ooh, exciting. Okay, so I get excited over the little things. Log base b of 2y plus 5 to the 3rd power over y plus 3 to the 3/2 power, and that whole thing divided by y to the 3rd power. Whew, so good. Now I'm not done because I see a complex fraction. I see a fraction being divided by a whole number, by y cubed, which I know I can change to a fraction, y cubed over 1. So how do we simplify if we have a fraction divided by a fraction? Multiply by the reciprocal. That was like in unison. Beautiful. So I would multiply this really by a 1 over y cubed. And that answer, so just to kind of give you that thought bubble, we're going to multiply by 1 over y cubed. And so our final answer would look like log base b of, when I multiply this by 1 over y cubed, it would become 2y plus 5 quantity cubed over y plus 3 to the 3/2 times y cubed. Now here's my question. Did I combine this into a single logarithm? Yeah, so I'm done. Nothing else to do to it. Don't have to bring the power out in front. And that would be as far as I could go. Any questions on that? Vince?
What do you have to multiply out the denominator?
Multiply out the denominator? Unfortunately, you can't because they're not the same base. If they were the same base, you're right, I would need to combine that. But since they're not, I can go ahead and leave it in that format. All right, that's good stuff. I'm going to give you the next 5 minutes to think through with your partner which of the following are correct and which are incorrect. I'm going to add a little bit more instructions to this. If it's incorrect, cross it out and see if you can make it true. If it's correct, just circle it. All right, go ahead and do that, and then if you had to change it, I'll just ask you to raise your hand with your group to see what you could have changed it to. No, the first one here, is this correct or is it incorrect? Correct. Beautiful. How about the next one, correct or incorrect? Incorrect. Can someone raise their hand and tell me what could you have done? Jeremiah?
So like the second part of the equation?
Yeah, like what could you do to make it true?
Oh, you just make it log base 4 x.
Yeah, of x times 1, aka x, would equal log base 4 of x plus log base 4 of 1. Excelente. All right, the next one, is this one true or is it false? False, does not work. How could we change it to make it work? Log of 30, yeah, 3 times 10. That would convert to a log of 3 plus a log of 10. Nice. All right, how about this next one up top here? Is this correct or incorrect? Incorrect. How could we change it to make it true? Log base 5 of x minus 1 over y would equal log base 5 of x minus 1 minus log base 5 of y. This is a very common mistake. Make sure if you made that mistake, you star it so you won't make it again. How about this last one, correct or incorrect? Correct. Beautiful. All right. Oh, I don't know what I did. I'm supposed to press pause, and that didn't work.